Okay, let's review a little bit. Who remembers what a transformation was? Hint, hint, look up. It's already up there. Okay, yes, Eamon? One-to-one mapping from the whole plane to the whole plane. It's called transformation. Was the mapping of the hemisphere to a map, was that a transformation?
Yes.
Was it a one-to-one mapping?
No.
Hemisphere to the map, remember that one?
No.
Yes, it was.
Yeah.
It was a one-to-one mapping, but is it a transformation? Why not? It wasn't a plane to a plane. It was actually three-dimensional, right? Hemisphere to a plane. So it's not it's not transformation, that example. But we are going to go over some transformation today, where it's one-to-one mapping from the whole plane to another, to the whole plane. Okay. Also, there was a special type of a transformation called, yes, isometry. What's an isometry? What was the key word on that one? Yes, Nicole, it's a review. Yes, it's a special type of transformation. Why is it special? Okay. Who remembers? Brianna?
Because like they're congruent, like every segment to the other segment. They're congruent.
Yeah, what's congruent? The length, right? Remember? So, remember, it says if a transformation maps every segment to a congruent segment, not just one segment, but every segment to a congruent segment, then it's called isometry, remember? And another name for this isometry was called congruence mapping. You guys remember? Okay, so if this transformation happens to be isometry, that means it preserves the distance. Yes? So from this, we had a theorem. Let's go to the theorem. Isometry maps a triangle to a congruent triangle. And this was really easy to prove because? Because of, yes. Yeah, with, first of all, you need the definition of the isometry. The mapping was in isometry. That's what makes it really easy, right? Because they have given us, as a given, that this mapping is isometry. If you have a triangle, here's a picture, and it maps to the other triangle, all the segments will have the same length, right? Therefore, the two triangles will be congruent by side, side, side. So you're right. The first step is, of course, because of the definition of the isometry, the corresponding sides are congruent. Then by side, 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 the two triangles are congruent. And from this theorem, if you remember, we got two corollaries. One of the corollaries said, of course, if the two triangles are congruent, what do you know about the corresponding parts of it? They're congruent. So in terms of the angles, guess what? Yeah, so here's the theorem. Corollary says an isometry maps an angle to a congruent angle. Right? That's obvious. Look at the triangles, right? What about polygons? What do you know about the area of the polygons then? Yes? It's going to be same because, after all, polygons are made up of a bunch of triangles. And if these two triangles are congruent, what do you know about two triangles? Area of the two congruent triangles. They're the same. So, an isometry maps a polygon to a polygon with the same area. That's what we learned. Now let's do some examples using these theorems and so forth and definition. Take a look at our first example. Function g maps every number to a number that is 6 more than its double.
Hey, I saw that.
So what this says then is, by the way, this is a function. It takes a number, right, input, and it gives you one number output, right? So function g maps every number to a number that is 6 more than its double. How would you represent this using function notation? That's what it says here. Express this fact using function notation. How about Nicholas?
Gx equals e to the x equals 2x plus 6.
Correct. So if they say function notation, actually the one on the right is a function notation. The one on the left, what kind of notation is this?
1, 2, 1.
This is the one on the left. This, okay, here's the function notation first of all, right? Because it says g of x equals 2x plus 6. whatever you plug in for your input, you get your output as 2x plus 6, right? Now, what is this notation called then? That's called mapping notation. Okay, so instead of function notation, mapping notation is simply, instead of equal sign, they use what? Arrow. Instead of parentheses, they use? That's all. Okay, that's the only difference. So sometimes they give it to you in mapping notation. Sometimes they give it to you in function notation.
Yes.
Right, Austin?
Yeah.
So why is this not written as 6 plus 2x, but why is it written as 2x plus 6, Austin?
Because it doesn't matter.
Well, yeah, for addition it doesn't matter, right? So, but what about if it said less than instead of more than? Would the order matter?
You could just say negative 6 plus 0.
Right. So how come when we have, it looks like you should have 6 first, then double, right? Because that's how it's written. How come we switch the order? Because of more than. Remember in algebra, more than means what? So more than what? Double of the x, right? So 2x plus 6. That's what it means. It doesn't mean the other way around. Does that make sense? Less than, of course, is going to matter a lot because it's subtraction. So if you write 6 minus 2x, would you get this right if it said less than? No. Okay, please be careful. Right? Less than means less than what? Whatever that they're talking about, you subtract 6 from that. All right, now it says find the image of 7. Let's look at the second one. What does that mean? Let's think about that. He says find the image of 7. Is 7 the image?
No, it's a pre-image.
That's what it looks like. It says find the image of 7. You're right. 7 is the pre-image, right?
Yeah.
Why? Because it says find the image of 7. Why is that the pre-image 7? Yes, sir.
Oh, because
Because it sounds like 7 is the image, and they want you to find the pre-image, doesn't it? It says find the image of 7. Are they saying 7 is the image? No, they want you to find. Okay, so anytime you get confused, what does image mean? This is the input or the output? Output. So they're saying find the output of 7, which is then 7 must be the input. Does that make sense? Please keep that in mind. So of course, if you want to find the image of 7, all you have to do is what?
plug it in.
Yeah, because 7 is your pre-image or your input. You plug in 7 into this function. You're basically looking for what? G of 7. Correct?
Equals 2 times 7.
Yes, G of 7 equals 2 times 7 plus 6, then gives you 20. Does that make sense?
Yeah.
What about the next one? Find the pre-image of 8. Is 8 the pre-image? No, we're looking for the pre-image. Remember pre-image, you could replace pre-images with word? Input. They're saying find the input of 8, which means what? Which input can you plug in so that you get 8 as your? 8 is then your? Is your input or the output? Which is the pre-image or the image? So 8 is the image, isn't that right? So they want you to find the pre-image of this image 8. Okay. So how would you do this? Samantha?
You said 8 equal to 2x plus 6.
Correct. You said 8 equals to 2x plus 6 because we know that g of x equals 2 of 6. 2x plus 6. So 2x plus 6 equals to 8. And we're looking for the value of x. That makes, right, this whole thing equal to 8. Does that make sense? Do we know how to solve for x? Subtract 6 from both sides divided by? Do you see how we get 1 as our input or the pre-image? Right? So please don't get these confused because on the test, this is the part where people mess up. They misunderstand when I say find the image of 7, they think 7 is the image, which is not true. If I say find the pre-image of 8, what is 8? 8 is the image. That's your output. What about it when I say find the image of 7? What is a 7? That's the pre-image, which is your input. Does that make sense? Okay. All right. All right. Now we're going to move on to an example of mapping. Okay. So here's mapping G maps each point x comma y. Now remember mapping. How many inputs does it have? More than 1. In this case, we're going to have 2 because we're going to talk about transformation. It's going from plane to plane, so it's going to have 2. So as you can see, my input has 2, right? It's an order pair, x, y. And it's what's the output? What is this output? 2x comma y minus 1, which is another order pair. Does that make sense? So as you can see, mapping is really similar to function. right? In function, you plug in a number and you get another number back. For mapping, you plug in an order pair and you get another order pair. That's what a mapping is. Does that make sense?
Yes.
So let's find then the mapping notation for this. What would the mapping notation for this mapping where G maps each point x comma y to the point 2x comma y minus 1? What would that be? By the way, if xy is 0, 0, what do you get as your output? 0, negative 1. If xy was 1, 1, what do you get? 2, 0, right? Do you get the idea? So how would you use mapping notation to represent? By the way, for mapping notation, what do we need? Instead of equal sign, we use arrow. Instead of parentheses, we use colon. So that's all. Okay, so that's the only difference. Don't get, So here, I'll show you the left side. It's going to look something like this, right? Why did I use the letter G? Because this is mapping G, right? If it said mapping F, I would have used mapping, And notice mappings, we use capital letters. So what would you write on the right side of this? G maps x, y, the order pair to what? That's why I read it, by the way. That's why it's called mapping notation, right? Instead of equal sign, it maps. Okay. So what would you say? G maps the order pair x, y to, how about Austin?
X, Y to N, 2XY minus 1.
What are you saying?
It's going to map, the output will be an order pair.
Y minus 1.
No, it would not be 2xy. It will be 2x comma y minus 1. Okay, so you get an order pair, right?
Yes.
So for the x coordinate, you're going to double it. For the y coordinate, you're going to subtract 1. That's what this mapping is doing. Easy enough? So take a look at part B. Find P prime and Q prime. The images of P, which is 3, 0, and Q, which is 1, 4. What are they asking you to do? Josh? Yeah, because when they say P prime, Q prime, is that your input or the output? Output. P prime, Q prime is your, is that the pre-image or the image? Image. They want you to find the image, right? Of, that's what it says right here, images of P and Q, right? So to find the image of P, which is 3, 0, Brandon, what would you do?
You would multiply 3 by 2 and then 4 minus 1.
Oh, no, P is 3, 0. So your x coordinate for P is 3 and then y coordinate is 0. So yeah, you would multiply 3 with 2 and then what do you do with the y coordinate of P?
0 minus 1.
Yeah, which is?
6 negative.
Yeah, you get 6 comma negative 1. Easy enough?
Yes.
Alright, then can you find Q can you find Q prime? When Q is 1, 4, what would that be? How about, hold on. Okay, so we have the mapping. Well, thank you for being honest here. We have the mapping going on. We got G of X. This mapping basically is multiplies the X coordinate with 2 and then subtracts the Y coordinate with 1, right? Now we're finding Q prime, which means that's your output, right? And your input is then what, 1, 4. So we're basically finding G of 1, 4. Isn't that what we're doing? So Poland, what would G of 1, 4 be? What do we do with the X coordinate? The mapping says you look at the mapping right here. G of X, Y, it does 2x comma Y minus 1, right? So if G, what would G of 1, 4 be?
2 times 1.
Yeah, 2 times 1 comma.
4 minus
Exactly. What do you get?
2 and 3.
Yeah. So that's your Q prime, your output. It's nothing hard. Okay. So basically, it's like function notation, except you have more than one input. Right? Now you have the input as an order pair. You get an output as an order pair. That's the only difference. Are you okay here? So we got P prime and Q prime. These are your images of P and Q. Okay. Now look at part C. It says decide whether G maps M, the midpoint of PQ, to M prime, the midpoint of P prime Q prime. What does that mean?
Find the midpoint.
Okay, so find the midpoint of what first? You're right.
PQ.
PQ. Do we know how to find the midpoint of PQ?
Yeah.
What do we use?
X plus.
Midpoint formula. The average of the x's, comma, average of the y's. Do we know how to find the m prime?
Yes.
What is that? The midpoint of
P prime and Q prime.
p prime and q prime. Use the same midpoint, right? Midpoint formula. But is that what they're asking you to do?
Oh.
They want you to decide whether G maps m to m prime. What's that mean?
It means
Okay, Kevin?
it means that if you plug in one ordered pair, the other ordered pair that comes out will be the midpoint of P prime.
Yeah, in other words, okay, exactly right. So go ahead and write it. If you're not so sure, don't worry about it. Just find me the m, midpoint of PQ, and then m prime, which is midpoint of P prime, Q prime. Go ahead, everybody find, and I'll show you what to do next. Go ahead, everybody do that first. Somebody tell me the midpoint of PQ, which is m. How about, let's see, who haven't I called? How about Jason? What's the midpoint of PQ? 2, 2. I forgot 2, 2 for that one. Very good. Okay, that's what I got. What about m prime? What's the midpoint of P prime, Q prime? How about Yechan?
4, 1.
4, 1, right? Because remember, you just, here, you add 6 plus 2 divided by 2, right? Negative 1 plus 3 divided by 2, don't you get 4, 1?
Yes.
Now, that's not all they were asking you to do. If you read the question carefully, they want you to decide whether the mapping, this G, maps m to m prime. What does that mean? Brianna?
You have to plug in the midpoint of PQ
Which is m, and see if,
and see if it like goes out to the other one.
yeah, see if maps to 4, 1, right? Because we don't know whether the midpoint of one segment, right? If you take the same mapping, it'll go to the midpoint of the other segment. Does that make sense? So how do we do that? Well, we just double D. So we plug in 2, 2 to the G of, we're basically finding G of what? 2, 2, isn't that right? And look, it comes out to 4, 1. So what can you say? It does map the midpoint to the midpoint of the other, right? G maps the midpoint of m to m prime. So here's the picture. And you may think, oh, that's obvious, right? I mean, if Q, look, P maps to P prime, Q maps to Q prime, of course M is going to map to M prime, but turns out this is not always obvious. Sometimes it will actually map somewhere else. It doesn't have to be in the middle, depending on what kind of transformation you have, okay? But in this case, it does. Does that make sense? And so if it does that, of course, midpoint of QM will be midpoint of just Q prime, M prime. Midpoint of M to P will be midpoint of M prime, P prime. In other words, every single order pairs here is going to line up nicely as a line segment, right? It's not going to be some kind of curve. You know what I mean? When you do this transformation. Does that make sense? So this transformation maps line segment to line segment. So is this an isometry?
Yes.
Uh-oh.
No, it's not.
How do we define whether or not this transformation is a special type, this isometry? Yes, Nicole? The length of it to be congruent. Now, any length or every length? Every length. So, can I compare this one and say this proves that this is a transformation called isometry? No, why not? You're right. Even if I look at the length of these two segments, I cannot prove that this is a isometry because does it compare every length or just one? In this case, it's just using one length, isn't it? So if you wanted to really prove whether or not this transformation is isometry, can you use some numerical values of these points, or do you have to use variables? Yeah, variables indicate, right? You have to use some variables, right, that represents transformation and look at the distance with those variables, right? Just by looking at the one case does not prove that this mapping is isometry. Does that make sense? But regardless, let's look at the distance of these two segments, whether or not it appears to be a isometry or not. Does that make sense? Because if the two segments have this different length, guess what? We know for sure it's not an isometry, right? Because we found that there's a counterexample. Does that make sense? You know what I'm talking about? So that's part D. Part D says what? Decide whether PQ equals P prime, Q prime. What does that mean? If there's no symbol, what does that mean? They're looking at the length of these segments. You guys remember that? Go ahead and find the, how do you find the length of segment? You use the distance formula. I mean, you could use the Pythagorean theorem, but don't you want to use the distance formula? Go ahead, everybody go ahead and use the distance formula. and tell me whether or not the length of these segments are equal or not. Go ahead, everybody try. I'll wait. So, how many people find the distance of PQ? How many people got 2 rad 5 for PQ? Okay, what about then P prime, Q prime? 4 rad. Okay, so as you can see, you know for sure this is what? Not in isometry. Now, even if the distance of these two segments came out the same, can you prove that it is? No, it may appear to be an isometry. You could say that, but you cannot. It doesn't prove, does it? Because this is one particular example. You have to look for every single distance of the segment, right? Every segment has to have the same distance. Does that make sense? And of course, in order to do that, you need algebraic proof. Yes? Any question? Can you do something like this for your homework tonight? Very good.